Okay, for this problem, we're going to take the derivative of natural log of tangent t over secant t plus 1. All right, let me tell you what I'm not going to do. What I'm not going to do is use the quotient rule. So one technique that would work is derivative of natural log is 1 over the inside, and then take the derivative of the inside using the quotient rule. That will work. It is also a big, big mess. And so I will not do that. Instead, what I will do is that we start with a property of logarithms. So I have the natural log of a quotient. And so I can write this as the natural log of the numerator minus the natural log of the denominator. And so I have simplified this considerably. There's no longer a quotient anywhere. And so the quotient rule is no longer necessary in order to find the derivative. And so taking the derivative, we get that y prime is equal to the derivative of natural log is 1 over tangent of t times the derivative of the inside, which is secant squared t. Then the derivative of secant t, natural log of secant t plus 1, well, we'll start off with 1 over secant t plus 1 times the derivative of the inside. Derivative of secant of t is secant of t times tangent of t. And then derivative of 1 is 0. And so this simplifies as secant squared t over tangent of t minus secant t tangent t over secant of t plus 1. Now, it is possible, it is not necessarily advisable, but it is certainly possible to take the derivative of natural log and then use the quotient rule, and you'll get an expression that turns out to be equivalent to this. That's not a wrong approach, but that is certainly a more lengthy approach to be able to find the derivative. However, I'm not going to take points off if you were to do that way and correctly use the steps to obtain the derivative. Okay, now for exam purposes, unless I say otherwise, that's probably going to be good enough for exam purposes. However, for the purposes of this video, I wanted to tell you that this actually simplifies considerably if we use some trig identities that you should be familiar with. So let's get a common denominator. So like I said, I'm going to stop here in brown. That's good enough for exam purposes unless I say otherwise. But let me continue simplifying this using some trig identities that you should be familiar with. So let's get a common denominator, secant squared of t times secant of t plus 1 minus secant of t times tangent squared of t all over tangent of t times secant of t plus 1. Okay, so that's just combining the two fractions. Okay, so we notice on top there is a secant of t that's common to everything. And so I can factor out a secant of t. What's left is going to be secant of t times secant of t plus 1 minus tangent squared t all over. And the bottom I'll keep the same, tangent of t times secant of t plus 1. Okay, so let me put this out separate. Secant of t divided by tangent of t. Now inside the brackets, I'll multiply out. We've got secant squared t plus secant of t minus tangent squared t. And on the bottom, I have secant of t plus 1. So far, I have not invoked any obscure trig identities. I've just simply been doing the algebra to be able to simplify this expression. Okay, now I'll start using trig identities. Equals. All right, so secant is 1 over cosine of t divided by tangent is sine of t over cosine of t. Now over here, I will invoke an important trig identity that you may have forgotten. And the trig identity goes like this. 1 plus tangent squared t is equal to secant squared t. That is one of the Pythagorean trig identities. And if we rewrite this, if I move the tangent squared over to the other side, I get 1 is equal to secant squared t minus tangent squared t. And here I see a secant squared t minus tangent squared t. So if I combine these two terms here, secant squared t minus tangent squared t is equal to 1. So this proves it to be secant of t plus 1. This secant of t comes along for the ride. Secant squared t minus tangent squared t is plus 1 over secant of t plus 1. And on the next step, that cancels. Also on the next step, cosine of t and cosine of t in the denominator both cancel. Alternatively, we can multiply by the reciprocal and the cosine t's cancel. And so this is equal to 1 over sine of t, which is simply equal to cosecant of t. So for exam purposes, this would have been just fine. This is not a class where I'm going to be, spending a lot of time on making sure that you have obscure trig identities memorized just for the sake of having obscure trig identities memorized. So for exam purposes, especially for a timed exam, this would be just fine. But I did want to point out that using techniques that you will be responsible for in this class, using trig identities, this can be simplified to only cosecant of t by itself.